Hi and welcome to this video on simultaneous equations, maths made easy. Here we're given two equations, each with two unknowns, and we're asked to solve. The equations can be two linear equations. In this case we rearrange the equations into the same form, ax plus by equals c. Always try having the x first, the y second equals c. Match up the coefficients of x or y, so if one of the coefficients is the same in both the equations, then that's great. We can solve by either adding the two equations or subtracting one from the other. If both equations have the coefficients which are the same with the same sign, then we subtract. If the coefficients are different signs, then we add the two equations. We solve the resulting equation and then substitute our x or y back into one of the original equations, and we get our result. The two simultaneous equations, each with two unknowns, we can be given only one can be linear and the other would have say an x squared in it, so it's non-linear. In this type of simultaneous equations, we'd rearrange the quadratic so that y equals something x squared. Rearrange the linear equation into this form again, ax plus by equals c. Then substitute the quadratic into the linear equation, so the y we'd substitute for the y in the linear equation. Rearrange and solve the resulting quadratic and we'll get two values for x. Substitute these two values for x back into one of the original equations and we'll get two values for y. Okay, so let's put this into practice. Here we're given two simultaneous equations. They're both linear. 3y plus 4x equals 10, 4x minus 2y equals 8. So this is already in the form that we want, the x first and then the y equals 8. Let's rearrange this, so moving the x to the other side, we get 4x plus 3y equals 10 and 4x minus 2y equals 8. We can see that these x's, the coefficients are the same and they're the same sign. So if we subtract 4x minus 4x, we're left with 0. So that will get rid of our x's. Then we're left with the y's. 3y minus 2y is 5y equals 10 minus 8 is 2. 5y equals 2. Divide 2 by 5, so y equals 2 divided by 5, which is 0.4. Then sub our 0.4 back into one of the equations. We're going to sub it into equation 2, and we get x equals 8 plus 4/5 divided by 4. So 8 plus 4/5 is 44 divided by 5. 44 divided by 5 divided by 4 is 2.2. Here we're given these two simultaneous equations. Yes, they're both linear. Rearrange them so that we can get the x's first, so that becomes minus 2x plus y equals 3. Here when we rearrange this, we get minus x plus y equals minus 1. We can see that the y's are the same. Here, just got one of each. So y minus y gets rid of that. Minus 2x minus x is minus x. 3 minus minus 1 is 4. X equals minus 4. Sub our minus 4 into equation 2, and we get y equals minus 4 minus 1. Y equals minus 5. In this case, none of the coefficients are the same, so we want to make one of the coefficients the same in both of the equations, so that it makes our life easier. So we can add them or subtract them like we did earlier. So choose one of the coefficients. So I'm going to choose here our 3 from our 3y, multiply equation 1 by 3, so that gives us 12x minus 6y equals minus 18. So we're going to multiply each term by 3. Don't forget to multiply the minus 6 as well. Then, because we chose this 3 from 3y, we have to use the 2 from the 2y in equation 1 and multiply the equation 2 by 2, and we get 10x plus 6y equals 40. When we do that, we find that our y's, because we chose these coefficients from the y, are the same. So we've got minus 6y here, plus 6y here, and then because they're different signs, we add minus 6y plus 6y is 0, so that gets rid of our y's. Add the 12x and the 10x, 22x, add the minus 18 plus the 40 so plus 22. So our x equals 1, substitute into equation 1, and we get y equals 5. Here we're given one equation with an x squared, so that's a quadratic, it's not linear. And here we're given a linear, so one nonlinear equation. Make this linear equation into y equals something, or if it isn't, if a y is by itself, then we can go straight ahead. Because this y can be substituted with this quadratic, so we can make the y equal this x squared minus 8. So here we would have x squared minus 8 minus 3x equals 10. Okay, so rearranging that, we get x squared minus 3x minus 8 equals 10. Make it equal to 0. So our quadratic equals 0. Then we can factorize that. Our factors of minus 18 are minus 6 and plus 3. Remember to change the signs. So our x equals minus 3 and x equals 6. Substitute that into equation 1. So substitute x equals minus 3 into equation 1. We get y equals 1. Substitute x equals 6 into equation 1. We get y equals 28. So we get 2 values for x, 2 values for y. Okay, here we've got y equals 3 multiplied by x squared plus 3 in brackets, so quadratic. Here we've got our linear. Rearrange our quadratic so that it becomes y equals 3x squared plus 9. 3 times x squared is 3x squared. 3 times 3, 9. Rearrange our equation 2 if needed. Here we don't need to, so we got the y by itself inside the equation. Substitute this y into equation 2, substitute the quadratic into the linear. So we're going to have 14x plus y, which is this quadratic 3 brackets x squared plus 3, which we arrange to be 3x squared plus 9. So we have 3x squared plus 9 plus 14x equals 1. Make it equal to 0. So the quadratic equals 0. Then we can factorize it. 3 times 8 is 24. So we want the factors of 24, which are 2 and 12, which add to make 14 when we're factorizing. Remember to change the signs. And also, because we multiplied by 3, divide by 3. So this would be then minus 2 divided by 3. X equals minus 2 divided by 3. And this would be minus 12 divided by 3, so x equals minus 4. So x equals minus 2/3 and x equals minus 4. Substitute that into one of the equations. So when x equals minus 2/3, y equals 31/3. And when x equals minus 4, y equals 57.